Okay, didn't quite finish this problem. We were in the midst of the quadratic formula and trying to get this guy solved. So we got down to square root of 380 can be simplified. So square root of 380 is 4 times square root of 95. That's going to be 2 times root 95. So this is 10 plus or minus 2i square root of 95. All of that over 10. So this is 10 over 10 plus 2i square root of 95 over 10. That simplifies into 1 plus or minus and I square root of 95, all of that over 5. So that is your solution. So this is why students from last year did not like the quadratic formula. It makes a problem long, so it'd been nice if this thing factored, but it did not. So moving on, can this be factored? So you could find the discriminant, or one thing, like I said, if you're real handy with factoring, you can just see, you'll know pretty quickly if it factors. Are there two numbers that multiply to give me a 24 and add to give me a negative 11? Okay, factors of 24, you get used to them after a while. It looks like a negative 3 and a negative 8. Those numbers will multiply to 24 and add to negative 11. So I could write this as 6x squared minus 3x minus 8x plus 4 is equal to 0, and then factor by grouping. So the first two terms have a 3x in common, so that leaves 2x minus 1. Bring down that minus sign. I could factor out a negative 4 from the first term, and so what do I multiply negative 4 to get a negative 8x? That would be a 2x. What do I multiply negative 4 by to get a positive 4? That's a negative 1. So now I see this 2x minus 1 occurs twice. I can factor that out. So this is 2x minus 1 times 3x minus 4 equals 0. Set each of these factors equal to 0, and you'll find that x is equal to 1/2 or x is equal to 4/3. Those are your two solutions. So this one, when I started to factor, and it did factor, I was working down the right path. I just keep on going, and that works out fine for me. And this one, so again, I could try to factor it. So are there two numbers that multiply to give you a negative 7 and add to give you a positive 3? Okay, in this case, the only factors of 7 are 1 and 7. So there is no way to add or subtract or anything with those numbers to get a 3. So I know factoring is not going to work. So I'm going to need to go to quadratic formula. So b squared minus 4ac, that's going to be equal to 3 squared minus 4 times 1 times negative 7. So that is 9 plus 28, which is 37. So again, the discriminant is not a perfect square. That's why it wouldn't factor. So x is equal to negative b plus or minus square root of b squared minus 4ac, all of that over 2a. So in our case, x is equal to the negative of b is negative 3 plus or minus square root of b squared minus 4ac is 37. Since we already found that number, over 2a, that's 2 times 1. So this is negative 3 plus or minus the square root of 37 over 2. 37 is a prime number. This can't simplify. So this is my solution. So x is equal to negative 3 plus or minus the square root of 37 over 2. Or if you wrote it, it's negative 3/2 plus or minus the square root of 37 over 2. Any of these solutions would be fine. Okay? Solve by any method. So here again, I want to see if it's factors first. Well, are there things that multiply to give me 50 and add to give me a 5? Well, maybe a 10 and 5. So I need two numbers that multiply to negative 50 and add to give me a 5. So if I had 5 and 10, and the 5 were negative, I multiply those numbers, I get a negative 50. I add those numbers, I get a 5. And now I can just say that this is x minus 5, x plus 10 equals 0. So x is equal to 5 or negative 10. Okay. Now, if you didn't see that, you could, look at the discriminant. So you could figure out b squared minus 4ac. So that's going to be 25. So if you look, b squared minus 4ac is going to be 25 minus 4 times 1 times negative 50. So that's plus 200. So I'm going to get, this is what, 225. Okay. So 225, that's fine. And it looks like that is what, 15 squared. So it's going to work out. If I did the quadratic formula, x is negative b, so that's negative 5 plus or minus the square root of 225 over 2a, which is 2. So this is negative 5 plus or minus 15 over 2. So take the plus sign. Negative 5 plus 15, that's 10 over 2, that's 5. Take the minus sign. Negative 5 minus 15 is minus 20 over 2, that's minus 10. I get the same two numbers, okay? Not too much extra work, but if we're solving by any method, either of these would have worked. So there's no one right way to get this to work for you. Let's look at the next one. X squared plus 7x equals 0. This one, don't overlook the fact this can factor. So x squared plus 7x equals 0 because there's no non-zero constant term. I can factor an x out, and I have x plus 7 equals 0. So I got two things multiplied to be 0. So either x equals 0 or x plus 7 equals 0, in which case x is equal to negative 7. So pretty easy to solve that by factoring, okay? And we have a couple more. Let's see if we can get these before I hit the 15-minute mark of this video. Solve by any method, okay? So if it factors, are there two numbers that multiply to give me a 1 and add to give me a negative 1? Well, the factors of 1 are just 1 and 1, or what, negative 1, negative 1. And there's no way to combine those numbers and get a negative 1. So as simple as this thing looks, this does not factor. So b squared minus 4ac, that's going to be negative 1 squared minus 4 times 1 times 1. This is 1 minus 4, which is negative 3, okay? So the discriminant is negative. I'm going to have complex roots. That's why this would not factor. So x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So x is equal to negative, b is negative 1. So plus or minus the square root of b squared minus 4ac, we already figured that out. That's negative 3. All of that over 2a, which is 2. So x is equal to 1 plus or minus the square root of negative 3, that's just I times the square root of 3, and all of this over 2. So you can leave your answer like that, or it can be written as 1/2 plus or minus the square root of 3 over 2 I. Any of these would be fine for your answer. Okay? One more, and then you should be turned loose to work on these on your homework. And again, there's really nothing new here. It's just all the methods being thrown together and you having to decipher which one to use. This one, pretty easy. I've got something squared by itself. So I'm going to take the square roots of both sides to solve this. So if x plus 7 squared is equal to minus 16, then I simply want to take the square root of both sides. When I take the square root of the left, I get what, x plus 7 equal plus or minus the square root of negative 16. So this is x plus 7 equals plus or minus, that's going to be what, 4i. And so x is equal to negative 7 plus or minus 4i. And that should be it. So that's it for this section. So this should be a good launching point for you to now work on the homework for this section. And again, all we're doing is combining all the methods we have for solving quadratic equations, the methods we've been working on. Now you've got all of these, work this section, and then the next time we're together, we'll be reviewing for an assessment. Okay, thanks.